a washer dryer to clean your clothes. Most of us, some of us wash by hand. That's cool. Go green. All right. Nikola Tesla had nothing to do with your washer dryer. Why would I bring that up? Well, it takes 240 volts of electricity to run those washer dryers. That's the same amount of electricity that we start with in our Tesla coil. So how do we take 240 volts and turn it into 1.5 million? Well, if you guys look up on the ceiling up there, you're going to see a large black box. Inside that black box is what's known as our primary coil. It's a wide copper wire wrapped around itself about 10 times. Now, when electricity moves through a wire, it generates what's called an electromagnetic field. That electromagnetic field can actually start electricity moving through nearby wires. Nearby wire up there is that large tube coming out of the black box. It's a thin copper wire, spiraled around a couple hundred times. It looks almost like a slinky. Now, every time electricity goes around the turns in that slinky, that voltage increases. It goes up and up and up until it hits the discharge gauge down there at the bottom, where it reaches 1.5 million volts. It looks just like this. Yikes. Now, that electricity travels 10 feet away from the discharge gauge to those aluminum grounding rings. All right, so the coils are made out of copper. Those grounding rings are made out of aluminum. These are materials that allow electricity to move through them very easily. Does anyone know what we call those kind of materials? Conductors, absolutely right. Conductors allow electricity to move through them very easily. What are some other examples of conductors besides copper or aluminum? Generators make electricity, that's not bad. What was the other one I heard over there? Water, that's a good one. What do we know that's made out of mostly water, like 85 to 90% water?
People.
Us, human beings, we are conductors of electricity. In fact, there are electrical signals moving through your body right now. All right, so human beings are conductors. What about air? Does air conduct electricity? We certainly see electricity move through the air, but does it actually conduct that electricity? No. Air is what's known as an insulator. It does not allow electricity to move through it very easily. That was one of the problems that Nikola Tesla had. All right, air does not conduct electricity. So air, glass, wood, rubber, these are all good examples of insulators. What are the benches you guys sitting on made out of? Plastic. It's another great example of an insulator. It's a good thing it is. Otherwise, you wouldn't be sitting there very long. Now, what I would like to do, I would like to invite as many volunteers as I can fit up on this stage as I discharge this thing one last time. Don't bother raising your hand, just come on up, grab yourself a spot on this stage, be careful. All right, no pushing, no shoving, very good. Now, I noticed that you guys didn't wait for me to say that this was perfectly safe and no one will get hurt. Does that matter to any of you guys up here? No, that's fantastic, that's great. All right, so here's the deal. I'm gonna discharge this thing one last time. Are you guys safe? What do you think? Yeah, you're like, why would you invite me up here anyway? You're gonna lose your job. Wrong, there's a disclaimer on the back of the ticket. Booyah! No, I'm just kidding. Listen, electricity wants to get to the best conductor the fastest. You guys, despite all of you being human beings, right? Anyone here not a human being? Okay. All of you guys being human beings, being conductors of electricity, you're about 40 feet away from that discharge gauge. Those aluminum grounding rings are 10 feet away from that discharge gauge. So in theory, no problem. You guys are standing here, it shouldn't be an issue. You just got the best seats in the house for this last discharge. All right? Well, we're gonna see. We're gonna find out. All right? Does anyone want to step down off the stage? I'll give you that opportunity right now. Everyone good? All right, good. What I need from you guys is a countdown. The loudest countdown you can give me. Both you guys on stage and you guys who are on the outside. All right, I'll give you the 5. You give me the 4, 3, 2, 1. The louder you are, the longer this thing goes off. Sound good? Are you guys ready? It sounds like it. I can't wait. I'm super psyched. Are you guys ready? Yeah! Here we go. 5, 4, 3, 2, Give our brave volunteers a round of applause. Excellent job, guys. My name is Devlin. If you guys have any questions about our Tesla coil or science source, please let me know. The next time our Tesla coil will discharge will be just about 30 minutes from now.